So there aren't many things in life that I really enjoy more than good, healthy, broken code. I mean, it's kind of something that we experience in our day-to-day lives all the time. There's nothing that we're ever going to do to write 100% perfect code. It's inevitable that we're going to be shipping things that are broken. It's inevitable that we're going to have to debug these things. We're going to have to debug them in production. We're going to have to, do whatever it is that we do to fix these things. So who am I? That light just got really bright. My name is Matt Robenolt. I am the lead operations engineer at Discuss. So first of all, does anybody know what Discuss is? A few people. Cool. I would like to note that I do not write JavaScript for Discuss. I am an operations engineer. I got roped into doing this with a project called Sentry. Sentry is an error aggregation and an error logging service. It's an open source project that originally came out of Python, and it has since evolved into us being able to aggregate exceptions from Ruby, Python, Erlang, Go, and JavaScript. So I came onto this thinking that the JavaScript client at the time was really, really poor, and I figured, well, this can't actually be that hard. I might as well just go at it and try to fix all the problems. Little did I know that browsers are really, really, really terrible at doing these types of things. So kind of before I go into things, I kind of want to kick it off by this little funny excerpt that I thought of. And I thought of, if an exception happens in production and nobody saw the Chrome debug console, did it actually happen? This is kind of something that happens all the time. We ship production code, all of our tests pass, things were fine, until users start complaining. And we have no idea why this actually happened. And we call this post-mortem debugging. So for people that aren't familiar, post-mortem debugging is the concept of an exception has happened. We don't have the information at the time, but we need some way to figure out what happened and debug it after the fact. So to go with post-mortem debugging, ideally we would like to know that these things happen before users start complaining to us. That's not a great user experience. People are reporting that things are broken and whatnot. We would like to be able to stay on top of these things and know that these things happen before they have to tell us. In an ideal world, these things would be covered by tests, right? We would write our tests, we would cover every test case, we would TDD the shit out of everything, and everything would be perfect and fine. In reality, humans are actually really hard at writing tests. And this is due to a large number of things. One of those being, we don't know all the test cases. We can't anticipate that our users are going to do something really, really, really stupid that we didn't think about. Users are going to click a button 8 million times thinking that it's not working when we didn't anticipate that that's going to happen. They're going to have some crazy combination of browser extensions and all this other stuff that who knows what they're doing. A lot of times we actually don't get tests at all. So that's the other side of things. We could be as meticulous as we want and write all these tests. But in reality, most things actually don't even have tests. So that doesn't help us at all. Also, QA processes are faulty for basically the same reason why writing tests are pretty faulty. So there's all the combinations of browsers. QA teams are expensive. There's a lot of different cases you have to test. And at the end of the day, you're still not going to do everything that every single user is going to test. Your users are your best QA team. They're the ones that are going to figure out what's broken. They're going to touch everything that you didn't even think was possible. And no matter what you do, bugs are still going to get into production. There's just nothing you're going to be able to do about it. We should just have better tooling to get around this and deal with these issues. So if you guys work on a product that users are using, if you're fortunate enough to have customer support or someone just emails you and says something's broken, typically you get something like this. You get someone that's angry and irate and just says, it doesn't work for me. Well, what do you want me to do about it? So we look at it, and if we're fortunate enough and we have an actual tech-savvy user, we can maybe get a screenshot of their Chrome console. We can somehow coerce them into opening this up, reproducing the bug, and we can maybe get a screenshot of something like this. This is probably the best case that we can get out of post-mortem debugging without doing anything fancy. So it ends up turning into actually a lot of this. It works for me. I'm not going to fix this because I don't know how to debug your problem. And our users usually can't give us enough information to help us fix this. So how do we begin to be more proactive about this? Like I said at the beginning, we want to be able to stay on top of this, and we want to be able to know these things before our users are actually telling us. We don't want to rely on them doing faulty screenshots and all this stuff to tell us, here's what happened. We don't want these reproduction steps. We want to actually see what happened in real time. We want to see what the stack trace is and all the information in the context. So we should start capturing our errors. And we start logging as much information automatically so that we can debug. We can get notified of these errors. We can track these on graphs. We can do all of this information in real time on behalf of our users before they start complaining and telling us that something's broken. So I'm going to start with the most obvious way of doing this. This one is my absolute favorite. So I'm sure we're all aware of this window.onerror thing. If you're not, the TLDR is a window.onerror is a global callback that is effectively a try-catch over your entire application. I also like to call it window.onNope. It's literally the worst way to capture an exception that you can imagine. The signature of the callback looks something like this. So it takes 3 arguments, the first one being a message, the URL of the file that caused the exception, and then the line number. In reality, you usually end up getting this cryptic script error message. If any of you have seen that before trying to debug things, I will explain what that is in more detail in a second. So kind of the problem with all of this is that out of these 3 arguments that we saw, none of these are an actual error object. They're just a message, URL, and a line number. So in practice, these 3 arguments end up looking something like this. We have some type error, we cannot read property foo of undefined. We have the URL that it happened, and we have the line number. At a glance, this actually looks really useful. We can drill into our code. We can see what is line 10. Oh, this line, something was probably faulty here, and we may be able to solve the problem with this. But your code is actually probably minified. Line 1 is your entire application. You have 1 million characters on this one really, really long line. Also, your JavaScript is likely being hosted on another domain. So we're talking a CDN or some extra subdomain or a cookieless domain or something like that. The problem with that is that these window.onerror is subject to CORS. So for the cross-origin request scripting. And what that means is when it gets to window.onerror, all you get is, Ben's shaking his head. It's something like that. It's cross-origin something. Resource share. Whatever. But in the end, what this actually means for you is you get script error. So if you have your JavaScript on a subdomain or a CDN or something that is, doesn't have the proper CORS headers and all the stuff to go with that, window.onerror does not actually tell you anything. It tells you script error, line 0, and an empty URL. So you have literally no idea what happened, just that something happened. Though, in newer versions of browsers, specifically Gecko 31 in Firefox and Chrome 28 started introducing a more expanded version of window.onerror. And what this looks like is they've given you two new arguments that are passed through. There's a column number and then an error object that's passed through. Now we have our error object. So I've been talking about these error objects. Well, why are they so important? Why is this better to work with than an actual the string message? Why is this better than that generic type error? Well, first of all, we get a stack trace from this. Or we can try to. And for those that aren't aware, a stack trace is just a record of the function calls up until this point within the current call stack. So it's a sequence of function calls. You've called A calls B, B calls C, and whatnot down through what they call as a call stack. Basically, when you're debugging something, if you don't have a stack trace, it makes things really, really difficult. It's probably a little bit more difficult to dig into the error because you can maybe see that this exception happened at this line, but you don't know how you actually got to that line. You don't know what function called that function. You don't know the order of events that preceded that. So to explore this, we're going to open up our favorite executable, Node. And we're just going to simply throw a new error with the message lol. I'm sure everybody has seen something like this. So this is what comes back when you just arbitrarily throw and do not catch an exception. So I'm going to break down what these individual pieces are. So at the beginning, we have the name. So in this case, we just threw a generic error. This would also be a type error or a reference error or something like that. And then we have the message. So this would be that long something is undefined or whatever. Or in this case, we just passed lol. And then below that, we have the actual stack trace. So we can break down the stack trace into frames. So each line of the stack trace gives us very useful information. So we have a caller. This is the function that was, this is the function of that frame. This is the source that function was called in. So in this case was events.js. The line number this came from, so line 95, and the column number. So for fun, we now have this property off of the error prototype.stack. For fun, does anybody know what this, the actual type of error.stack actually is? It is a string. Probably the most useless thing that you can get back from this. So the way, if you want to start breaking this apart and you want to extract the pieces out of it, you need to use a regular expression, something like this. And this is also, note, this is very specific for a V8 stack trace. So what's this begin to look like in practice? So here I've written some really bad code. We can see that we have a function showThing. This showThing takes an arbitrary index as an argument. We expect this index to exist in this arbitrary things array, and we're calling the foo property on it. As we could probably denote, if we call it the showThing 1, the result of things index is going to be undefined. And undefined does not have a property foo. So if we fire up Node again and we want to actually execute this, we will see it does, in fact, throw a type error. And to go with that, we can see this very useful stack trace. So we see the type error cannot read property, blah, blah, blah. But then we see right below that, we can see that it was within the showThing function. So within that showThing function, it also tells us exactly what line number it happened, and actually exactly what column number raised the exception. And then if we keep traversing down the stack, we see line 12, which was exactly where showThing was called. It's an anonymous function, so it doesn't have a name in the call stack. If you also note, Firefox does something very drastically different. It's the same concept. You still have the stack property, but since it's a string, these things are formatted completely different. So there is no standard around how these stack traces are formatted. So if we were to write something that extracted all of these different components and all of these things for different browsers, also note this changes per version of browser. So this is not even just all of Firefox. This is Firefox 14 versus Firefox 25 versus whatever. Same for Chrome, same for Safari. All of these things are different formats. So if we were to write something, we have to write a bunch of crazy regular expressions to capture all of these different cases. And we have to also sort of feature detect to determine which ones are going to give us this type of stack trace. So now if we go into minifying our code, if we minify that exact code, we end up with something like this. It should be relatively parsable. It's pretty small. But we can see that through minification, we've removed all the white space, and we've also shortened our symbol names. So in this case, if we look closely, there is a function n. This signifies what showThing was previously. So if we run this again, we indeed get the exact same exception, except now we get line 1, column 125. This now gets a little bit more complicated to debug and figure out what's going on, right? In this case, it's probably still kind of deductible, but we only have basically one function in play. If this was our application, this might actually be column 20,000. And we also see in the stack it happened at function n. What is n? There could be multiple n's now through minification. We have no idea what's actually happening here. We're very clueless at this point. This is how things are shipped in production, usually. So something was invented, source maps. I'm not sure of the exact purpose that these were invented for, probably with CoffeeScript and all this other stuff, but the fact of the matter is we now have these source maps. And these source maps are it's a map of minified tokens to portions in the original source. So kind of what this actually means is, if we look at our source map for our min.js, we get our line 1, column 125. What the source map will tell us is that you're actually looking at line 9, column 30 of the unminified JavaScript. And it will also translate that symbol n to show thing. So now we're kind of making some progress. We can apply a source map to our minified source. We see this exception, random exception. We're able to actually get back what we would have if we weren't running minified source. But the caveat is that source maps require three things to actually be useful. One is the file name, obviously, the script that it's coming from, the line number, and the column number. Without all three of these pieces of information, a source map is literally useless. There's nothing you could do. If you just have a line number, you have line 1. What are you going to do with line 1? And unfortunately, column numbers are actually pretty rare to get. It's getting better through modern Chrome. And Firefox oddly gives you the column number of the top frame. None of the other frames. It only gives you the top frame. Don't know why, but that's the way it works. Internet Explorer, just good luck. No idea. You get terrible things from that. Window.onerror also has only a line number, as we originally pointed out. So if we look at this line in Firefox, so we have one of our frames. We can see that we get everything except that nice little column number that we would like. I'm not even going to explain Internet Explorer, but if you want to have some fun and torture yourself, please feel free to explore this stuff in Internet Explorer, because it's a riot. So also, this error.prototype.stack, being a string really, really sucks. We need to keep track of all these different regular expressions. We need to keep track of the evolution of all these browsers. And the bottom line is there is no standard around this. So we can't just come up with one regular expression that solves the problem for everybody. We have all this feature detection. We have to determine what version of Firefox to parse that specific exception out. We just have a mess. So V8 came out with something a while ago that is really, really interesting. I don't know if this is necessarily the best option out there, but it's probably by far the most useful today. Unfortunately, it's only V8, but they've introduced what they call this callsite API. And this is similar. This is access to these raw frames. So if anyone that has worked with Python and debugged actual stack traces in Python you're able to literally traverse the frames programmatically. You're able to walk up the tree. And within that tree, you're able to access all the local variables in each of the frames. So I can say, what was the previous call, which would be analogous to arguments.caller. You can walk up this tree, and you could say, what functions were in this scope? You can walk up the next tree, or the next frame, and you can say, what functions are in this scope? And this is extremely useful. So we can see that when we got into this show thing function, we may see that something was undefined, but we don't know why it was undefined because we don't have the variable that was actually passed through. We don't have access to these local variables. So this callsite API is starting to head that direction. I don't know if the ability is there to actually do all the local variables, but it's getting us so that we can avoid parsing these stack traces. So what it introduces kind of as the basics is this error.prepare stack trace. And this error.prepare stack trace is a global callback, which for what it's worth is probably a pretty terrible idea as well, because people conflict with this. What you do with this prepare stack trace is you're able to tell the engine, how do you actually want to parse the stack trace? So the default callback to error.prepare stack trace is what we would see in V8. It's the string representation of what our frames were. But since it's been exposed, we can actually use this to our advantage. We can tell V8 how to transform these raw callsite objects into what we want as the error.prototype.stack property. Or we can actually not parse them at all, which is actually what we want to do. So in this case of a callback that we pass to error.prepare stack trace, we get two arguments are passed through, the actual error object and then the frames. If we just simply return the frames from this, we have access to the raw callsite objects. Error.stack is no longer a string. So if we want to loop over all of these frames, we have access to these getter functions, like get function name, get line number, get column number. And now we don't have to parse regular expressions. So this is a very good step in the right direction. Basically, this is probably the most useful information you can get out of it. There's a bunch of other functions you can get out of it. But I think this is at least heading in the right direction. The problem that we have with the error.prepare stack trace is, again, like I said, because it's a global. So if one thing is trying to do something different with its error.prepare stack trace, and you're trying to do something different, you have conflicts. So you need to do this roundabout logic of setting it to some variable, overriding what it is, and inside your callback, call this function to get the functionality. But again, because we're accessing this .stack off of these errors, we get into a lot of funky race conditions. So in practice, this ends up not being too useful if you do anything in Node and you work with CoffeeScript. CoffeeScript is a really good example. They override this error.prepare stack trace to give you a better .stack representation, so you can utilize that when you're debugging. What happens is if you try to inject this, you are now conflicting what they're doing. So either you're going to break what they're doing, or they're going to break what you're doing. So error objects are pretty cool. So we have a much better use of these as opposed to these string stack traces. Now how do we actually collect these differently? We have this lovely try-catch. So very simple, we have something like this. We have our function, we're calling do stuff, and we want to catch the error. And then in our ideal world, we want to log this error, and then we want to rethrow the error. The reason why we're rethrowing the error is because to us, this is an uncaught exception. We don't know how to handle this. Our program should not continue executing after an exception has happened. So we want to rethrow it until we fix a bug. So the fun part right here is this log error. So once we're able to catch the exception, we're actually able to extract all this information and do something very, very useful with this error object. But try-catch is not very, very scalable. It involves you having to predict where your code is going to break. You're going to wrap every function in a try-catch and hope that you've actually wrapped the right thing. And if you don't, it's going to bubble back up to window.onerror and you're back to where you started with. So what we need to do is we need to wrap everything. So we need to wrap something in I guess what we call in Python is a decorator, but some just type of function that calls your other function. So you just call this wrap function and pass the argument of the function you're actually calling, and this would do the magic for you in a very generic way. So the way this looks is the only thing we had to change is this first line. We just wrap our entire outer function with a wrap. There's going to be some caveats with that because that obviously is within the current stack. So anything that you call as an async callback is not going to be within this stack. So you would have to wrap all of the your async callbacks as well in this wrap. So that sounds pretty cumbersome as well. So kind of the last thing that I want to touch on real quick is Sentry. So as I talked about, that I'm a core contributor to Sentry. And we have this library to go along with Sentry called Raven.js. So Raven.js's job is to do all these terrible things for you. We do this through means of monkey patching. We patch libraries. We patch into libraries exception handlers. So for example, Angular has this global callback, which is effectively their window.onerror. We inject into all of these things, and we try to capture all of these things for you. And then we send that along to a server. So we monkey patch. We also monkey patch the native objects. So we monkey patch set timeout, set interval. Like, it gets pretty obtrusive, but it does its job. The Raven parses the error, reports the information to the Sentry server. Then Sentry will fetch your source maps and give you a nice clean view of your error. So if you publish your stuff and you have your source maps as well, we will see the exception and we say, hey, here's the source map. Let's actually make this pretty. And if your exception has the line number and the column number, we can actually give you a view that looks something like this. So this would be a view inside Sentry. And we can see that we had some exception. And we can actually see the nice full stack that you should get if you were trying to debug this yourself. But the nice thing is that you didn't actually do this yourself. This was something that a user did this. User invoked this error somehow. We get alerted, and we saw this in Sentry. So I'm kind of calling out that I would like to help make this stuff better. And by this, I mean exception handling in browsers. I would like to see if there's some way to get standards going on or trying to make this callsite API or something that makes this process better. Exception handling should be pretty simple. Python is by far probably the best example of this, in my opinion. I want to help with this process. I want to be involved in Mozilla tickets. I want to help Firefox get up to par with how these things work. And I want to understand why maybe some of these decisions were being made. So to kind of summarize, I have a few references of these projects that I've talked about. So obviously Sentry, Raven.js. Then there was this browser stacks project that we put together, which was really interesting. And what this does is it uses Sauce Labs to capture a call stack across every single browser they support. So if you want some laughs, check that out. We have iPhones, Internet Explorer, every single browser. They all literally do something completely different. There's also a really nice library called stacktrace.js that helps do some parsing and do some logic that I've talked about. Zone.js is really interesting. Zone.js kind of does a lot of what Raven.js does, but Zone.js takes that to an extreme. It literally monkey patches everything and gives you these crazy contexts for, so nothing really gets to window.onerror. Every execution has its own context that is captured. And then also there's documentation for that new JavaScript stack trace API, the callsite API. So that's it. So, and apparently I was told that we don't do questions anymore. So someone will please pull me aside later and I can talk about this stuff for a really, really long time. So.